Now let's look at the model effect on the grand average scale. So this is all the subjects we had. There are 18 healthy controls and there are 23 sickle cell disease patients having around the age of 20 and about the same size female male. You can see that the hemoglobin deficit is definitely there on the sickle cell disease side, and there are cases of silent and overt stroke in sickle cell disease. And for all of these patients with, all of these subjects, which is 41, this is the grand average of their signal before. You can appreciate the PPG amplitude here on the top from 0 back to 3 back. And I apologize, there's no legend, but the solid line is the median of these signals, and the dotted or dashed line is the mean of all the averages. So again, this is the combined average or ensemble average of all 41 subjects. And you can see that for difficult tasks, there is more pronounced vasoconstriction that would probably affect our signal here. So this is second row showing the entitled CO2. You can see they build up a bit, but that's not so dramatic. But we included this in our model anyways. You can see the orange here is the oxygenated hemoglobin that showed gradual increase in the slope as we give more difficult task. And of course, deoxyhemoglobin would be more like an opposite of the oxyhemoglobin, so that here on the difficult task you can see there's much less, indicating that there were more blood flow recruited in the brain. Now again, this is before, but after the modeling or model-based filtering, you can see that the oxygenated hemoglobin pattern, especially on these difficult tasks 2 and 3 back, you can see it's much more pronounced in terms of increase in the slope. And you notice that there is this highlighted region because we strategically jumped or skipped the first 10 seconds after the task onset, because that's where the transition had been happening, and it's more like a less stable region to fit the slope. So for example, if I start fitting my linear line from this onset 0, then it'll be more flat, but then after I skip or jump to the 10-second and then fit the slope, then you can see that's much more reliable, so to speak. Now we are more confident in our signal that our FNIRS measurement is now refined to become more brain component, and we can now compare between two groups. You can see there's 0 back to 3 back responses, all ensemble averaged. Green is the control group, and the red is the sickle cell disease group. You notice that for both groups there were upward trend towards the difficult task. However, what to note is that for the second or 2 back task, we can say there was a pronounced increase in sickle cell disease compared to controls, which is also shown that there was a marginal difference between the sickle cell disease and control group as a p-value of 0.06, although it's not shown here. How about their behavioral score? So let's look at the response time here. First of all, I did the transformation, log transformation, to make their distribution more normal. So I can do parametric testing, and based on that, we can see that we found a slower response time during the 1 back in sickle cell disease group. And in terms of the accuracy, very interestingly, there was no difference between the two groups, suggesting in sickle cell disease the response time was longer, and for difficult tasks the group required more brain power to do the same task, which may suggest the less efficient nature of the processing in sickle cell disease. And this was published in Neurophotonics recently, where we showed hyperactivation nature of prefrontal cortex in sickle cell disease group while they're completing a working memory task. And what we're happy about is that we sort of showed or suggest an important basis for understanding cognitive decline in sickle cell disease, and at the same time we highlighted the potential utility of FNIRS for evaluating cognitive functions. So I think that's a wrap. So I hope you really enjoy the rest of Dr. Ku's course. And I hope you appreciated those two major methodologies to actually better quantify our physiological and brain responses. And of course, feel free to reach me if you have any question.